In this video, we're going to explore and dive a little into Windows API, and I'm going to start with a simple call to the Python open function, just to open a file, and we'll see what is the journey that this call takes. For this, I'm going to open the Python interpreter, begin the open call over here. File is going to be from my user profile directory. Let's say hello world.txt. Let's say I want write permissions for this. Before actually calling this function, I'm going to open the Windows debugger, windbg. And I'm going to attach to Python. So I'm going to click here on attach to process, and then double click here on Python. Now the function I want to put the breakpoint on is going to be the create file function. I'm going to use the W version. That's going to be the Unicode version. That is the function that Python calls. You can see we have here a bunch of arguments, but just remember that the first argument is the file we want to open. For this, I'm going to use the bm command. This is the Windows debugger command that places a breakpoint on everything that matches a certain pattern. So I'm going to start with a wildcard and then exclamation point. This will match all the modules. And then I want to match modules that contain the function create file w. Now you can see it placed the breakpoint on a couple of modules over here, and it's going to land on one of them. So I'm just going to let it continue for now. I'm going to run the g command to continue. And now I'm going to run the open function on Python. Now you can see we got a breakpoint here and it landed on kernel base. Now, why is it kernel base and not kernel 32? Microsoft decided at some point to move part of the functionality of kernel 32 to kernel base. Now if we take a look at RCX, I just run R and then RCX. We get an address over here. I can copy this address by just marking this and then right-clicking my mouse on this. Now I just run the du command, that's going to be display Unicode, and then right-click again my mouse. And we can see the file right over here. So this is the correct call. Now let's dive in a little deeper. So I'm going to put a breakpoint on the next level of this function. Create file basically in the end calls anti-create file. This is the native API function. This is a thin layer between user mode and the kernel. So I'm just going to put the breakpoint on this function. This will come from ntdll. And now I'm just going to continue execution with the g command. And we can see now we landed on this function. If I run the k command, you can see all the stack, the crazy stack that is going on from Python. And then it's going to use crt over here. This is the C library function, so you can see it's using the w open function. And the C library is calling create file from Windows API. And create file is calling ntdll anti-create file. And if we step here a little just by pressing F10, you can see that eventually we just arrived at the syscall instruction. So from this instruction, it's just going to go to the Windows kernel and do the actual work over there. To see what is going on in the kernel, you're going to need to kernel debug this computer. If you want information about that, I have a video on how you can set up kernel debugging. Now I'm going to show you one more thing. So I'm going to go here to the Visual Studio Build Tools. I have here the native tools command prompt. And let's navigate to C Windows and System32. And I'm going to use a program from the Visual Studio Build Tools that is called dumpvin. And I'm going to run this, for example, on kernel base, one of the modules that we saw before. And that's going to be .dll. And you can see that if I just run it like this, I don't get a lot of information about this DLL, just some basic summary information. But I can go ahead and run this with the exports flag. Now you see I'm getting a really long list of a lot of functions that this module is exporting. I can also use the find command to filter specific stuff. For example, I want to see only the create file stuff. And here's exactly the create file W that we saw before. You can see here the RVA address. This is a relative address that is updated when the module is loaded to the actual address in memory. And here's the ordinal of this function. This is just an identification number of each function that is exported by this DLL. In the same way, I can run this on ntdll, which is the DLL that implements the native API. And you can see over here the lower level functions. This is anti-create file that we saw before. And the cool thing is that you can also run this on the Windows kernel, which is called ntos kernel.exe. And you can see it also exports empty create file. That's because this functionality also exists in the kernel. Subscribe for more programming videos, and thanks for watching.